We turned NASA's static charts into animated data stories like this one. And now I'll show you how we did it. Hello there, Vizu enthusiasts! Great news! Some people from NASA's Jet Propulsion Laboratory reached out to us a couple of weeks ago. We expected that they want to offer us a seat in a space shuttle and bring someone from the Vizu team to the ISS to analyze the effects of zero gravity on animated charts and data stories. Sadly, that wasn't the case. Instead, it turned out that some of them are already using our open source Python tools ipyvizzu and ipyvizzu-story, and they asked us to introduce these to a group of scientists working at NASA as part of their Open Developer Meetup series. We were, of course, super happy to do this. You could say the news catapulted us to the stratosphere. They even sent us a sample dataset and showed the charts they built so that we can reconstruct them using ipyvizzu and show the people at the meetup how these could be turned into animated data stories so they can have an impression about how our tools could be put to good use when communicating the results of scientific research. The meetup was 2 weeks ago, and based on the feedback from the organizers, it was a major success with over 70 people attending from JPL. We also had the pleasure to share the stage with Dr. Raphael Attier, a solar physicist at NASA's Goddard Space Flight Center, presenting a data story about solar flares he built using our tools. The recording of the meetup talks will be available, and we'll share those with you on our channels once the post-production is ready. Until then, we thought we'd show you the animated data stories we built and explain our approach. So let's dive in. So this is what the scientists at NASA created from the same data set that they shared with us. This data is about how different factors changed over time in the ocean, namely the sea level, the ocean heat content, and the ocean heat uptake between 2003 and 2020. And we created 6 short stories. The first 3 shows how you could introduce such a complex data set to a new audience. And then the other 3 is how you could share and introduce what lies within the data when you're presenting your insights. So as with such a complex data set, actually a very easy technique to use is to add the components one by one. So here we see the total sea level, and then we add the ocean mass, the thermal expansion, and then at the end, the residual. It's easy as that. You might also notice that there's this lighter area around the lines. It represents the uncertainty of the measurement. You might also want to talk about that and what it means. So you could start your story by showing just this lighter area and then add the line to say and out loud what it represents and to direct your audience's attention to that. You could do that with all 4 components at the same time. So you show first the uncertainty, and then the mean of these measurements. And then at this point, I think you can also already remove the grayish area representing the uncertainty, because it's actually the lines the mean that matters the most. And then the third technique to introduce such a complex data set is not to show the whole timeline at first, but start with a smaller segment and then extend or zoom out as time progresses, and then you can already tell like certain changes and explain them that happened throughout this period. So for example, between 2003 and 2010, all 4 factors show the steady growth, whereas between 2020 and 2012 there was a noticeable dip here that you might want to explain. Again, we're not oceanographers, so we don't really know what those mean, but that's definitely a change there. And if we fast forward to the mid-2013, it seems there's also like a sudden dip and a sudden decrease in the measurements. But no, it was actually very local, and the steady growth continued. There's also a period between 2017 and 2018 when we have no measurements for 3 of the factors that obviously you would want to talk about. And then at the end, we just zoom out and we can share the audience that this is all the data that we have. Okay, now how you could turn these charts into a story. So the most logical one would be to connect the 3, so to morph from one to the other, but that requires some basic understanding of the connection between these charts. So first of all, there are some subtle differences that I want to raise your attention to. So we have total sea level here marked with black, and then ocean mass marked with blue. Whereas in the second chart, actually with the same color, it's marked total sea level minus ocean mass. So the difference between these 2 factors that you might want to talk about. Also, the orange line is titled here thermal expansion parenthesis Argo. Here it's called Argo observations. We thought it's pretty much the same, so we used the same name for it in our case. And here, this one, the red line is called residual. This way it's called difference. We again like you used them as equivalents, even though we don't know if they really are. But it's also it shows that it's important to have the titles and the categories like be very thoughtful of the naming that you use. So here with the first story, we have again the original chart showing the sea level. So we first hide the total sea level and the ocean mass and show their difference instead, as in the second chart. And then now we can very easily just morph from the sea level to the ocean heat content data. And if I go back and forth, you can see that there isn't that much of a difference between the two types of measurements, which can be a good way. So, with two ways we measured the same change. That actually can be important in a scientific measurement. Now, moving over to the ocean heat uptake can be a little challenging, because as you can see here, we have one data point for each month, and here we only have one data point for each year. So first we have to again morph from with still keeping the ocean heat content on the chart to a yearly average, which we can do with using ipyvizzu, and then we have the chance to change the data that is shown on the chart to the ocean heat uptake. We had to remove the residual first, and then we morph to the ocean heat uptake, and we add at last the SARAS top of atmosphere data that only appears on this chart. And as you can see, there's like a really significant change considering how these lines align from one chart, so from the ocean heat content to the ocean heat uptake. I have no idea what's behind that, but this is just one way to tell this story. And also, you might want to tell the story of the relationship between these components, because actually the total sea level is the residual plus the ocean mass plus the thermal expansion. And you can tell a story of this, like you show the total sea level first and show the ocean mass as the second component, then simply subtract the ocean mass from this total sea level, which will be the total sea level minus the ocean mass, which we showed in the previous story. And then we can also show the thermal expansion and subtract that from this blue line, and that will end up being the residual. So in a very easy way, using these animated transitions, we could really like just tell a simple story of the relationship between the components. We could also do this the other way. So if we show the residual, the thermal expansion, and the ocean mass, and turn these lines into areas, which are much better for actually stacking them on top of each other. We do that with areas, and we never do that with lines. Then it will be very easy to understand for the members of the audience that the total of these three components actually equals to the total sea level. So it's like that. Also, if you use the area chart, you could do this with Vizu and show how much these components contribute to the total sea level. And as you can see, there are some certain changes over time. So here it's pretty common that over like 50% of it comes from ocean mass, where here the residual starts to grow very rapidly, and then it shrinks and then it grows again. Here's obviously the period where we only have thermal expansion data, and towards the end it gets very messy. But there are actually very significant changes here that might need some sort of explanation. Now lastly, so these charts behave very well actually. At first glance, you would think it's not even oceanographic data, but some sort of mission control data showing how space shuttle went to the International Space Station, and they met at the very end. But actually the data shown here is showing changes compared to the last point in time, so the closest to the present. So this is considered zero or around zero, and then everything shown on the other parts of the chart shows the difference to like the last measurement, so the delta. And yeah, in order to make that very clear, and also to raise the attention to certain changes, you can just change your point of reference very easily, and like to 2011 May, which is the bottom of this dip that I mentioned before, or July 2010, which is the top part here. So as you can see, these new views can open up new explanations and show different relations between these components. You could move further back the point of reference to this and even to the very beginning. And so it would be clear for the audience that these show relationships and not absolute, but relative changes in these factors, which can be a great way to tell a story. So these were all the stories we wanted to show you this time. You can find all of these, the data, the exported HTML, the code of the stories, and some intro material is used during the meetup. If you go to bit.ly/vizu_at_jpl, as you can see now on the screen. And yeah, we just wanted to say thanks once again to Louis McGibney and Kai Pak from Jet Propulsion Laboratory and Dr. Raphael Attier from the Goddard Space Flight Center for making this all happen. Once we have the video from the meetup, we'll also share that with you on our channels. Until then, happy visuing everyone, and thanks for watching.